Hi, this is Ted Gartland from E. Gartland and Associates. I put together a quick PowerPoint to discuss the sensitivity of different leak detectors and what it means in the real world to have a refrigerant detector that can read 1 part per million or one that can read 100 parts per million. And what does that actually mean to you? I carry the Bacharach line of leak detection systems, and they make a whole lineup of different types and different sensitivities and different gas types, get different sensors, etc. And they come in all different kinds of prices as well. The what I'm talking about here is refrigerant, and the main unit that you'll see out there sometimes is private labeled by other companies is what they call their MZ unit. The MZ unit is a wall mounted unit with a 10-inch infrared sensor, which the 10 inches gives you the 1 part per million accuracy. Now, this particular one is also self-calibrating. It can handle many different refrigerant types. It has a whole library of them in there, including some of the newest ones that are out on the market. It can cover up to 16 zones, and you can split those zones up to 3 ways, so you can really cover a huge amount of area. And the reason it can do that is it has a pump in there that can pull up to 1,200 foot of length through their 1/4 inch tubing that you run around the place, around the store or whatever site you're working on. The second type unit is Bacharach makes a number of different ones. Is the in this case it's the MGS 250, MGS 550. They make and they also make one that's a 150. Some of them have infrared, some of them do not. Now, this particular one has a carb mode that can read down to 10 parts per million, but in the real world, if you run it at that, you're probably going to have a lot of false alarms. So realistically, 75 to 100 is more what you would expect. One of the nice things about these, though, is that you put one in a space, you don't have to run tubing or anything, but that also limits its ability because it's only going to get the refrigerant that goes by in front of it. And thirdly, we have the wall-mounted unit in a bag. This is what we call the portable area gas monitor. This has the same sensor as this one and can get down to 1 part per million. I put get together a couple of videos that I'll put up on it that will show you just how important that is. So one of the things that Bacharach came up with was a model. I don't know if they offer this to other folks or not, but it basically takes the characteristics of the refrigerant over here and it models them on the size of the room and how much refrigerant is being leaked into that space and how much the air is changing over time. So with that, they'll come out with the parts per million over per hour and how it rises over time. In this case, I used an example of a 960 cubic foot walk-in cooler, sort of a common size, a 10 by 12 by 8, that has a coil that is running R404A and is leaking. And I did the leaks in different sizes, which will be on the next slide, all the way from 1/2 pound, which is a pretty small leak, 1/2 pound per day, all the way up to 10 pounds a day, which is a huge leak. So where do I get my air changes from? Well, I went to the Heatcraft engineering guide. They have a nice couple charts on there that show what they recommend. And what I notice on the chart is the smaller the volume, the higher the air changes, and then the larger, the lower the air changes. So that makes a lot of sense. In this case, we're around 1,000, so I used 13 air changes. And what that would mean is that every time someone opens that door, that refrigerant probably pours right out, and the air is changed. Now at nighttime that wouldn't happen. You'd have more of a chance for that parts per million to rise, but in the real world, that door's being opened and closed. So what is the conclusion? What happens? Well, in this case, again, I have my parts per million level here on the left axis and the hours on the bottom axis. And the different colors are the amounts of refrigerant is leaking: 10 pounds, 5 pounds, 1 pound a day, and 1/2 pound. On the left here, you'll see this is one of the point detectors. It has a realistic parts per million accuracy around 100, and I put a straight dashed line there. In other words, what will alarm that unit. Then I have the MZ here with the 10-inch infrared sensor, which can be set down, could be set down as low as 1, but most people set it at 5 to 10 parts per million. And what happens in the real world is that if I have a huge leak, you probably could hear that one, this one will go off. And that's good for safety because you're obviously going to be displacing a lot of the air in this time with refrigerant, and you wouldn't want to be working in there with that kind of a leak. So this would definitely go off and alert you to that. But what about a 5 pound per day leak? It would only get up to 65 parts per million, so it would not go off. But if you look at the MZ, it goes off on every single one of these leaks. And that's a real, that's real world because you are going to lower your leak rates with a more sensitive unit. You're going to pay more. Well, not actually per zone. You're not going to pay more if you use all the zones, but you're going to certainly get better results. Now let's take another example where maybe that would be even harder to detect a leak. And that would be, let's say you have an open deck aisle and you have a pretty large leak. In this case, I'm saying you're leaking 1 can of 404A a day, which is a pretty large leak. And then that leak, let's say, is in this case here, and it's dissipating into the air, dispersing, diffusing, scattering, however you want to say it. It's going into this space here. Because of the volume and the air changes, which aren't really very high in this case, your parts per million level over time is really never going to get over 65. And I would say that those parts per million with doors opening might even be lower than that because your air changes with all the fans blowing are probably actually higher than that. So this isn't going to get over 40. Well, guess what? Your MZ, if you had, let's say you had a sensor over here in the back corner or somewhere over here or wherever, it's going to find that leak. It's going to get pushed around and it's going to end up over and hitting that sensor and setting it off. So, in the real world, what are my choices? I have, and it's becoming more and more of a case that people want to have safe space detectors in their enclosed spaces. Well, if you have a smaller store where you don't have a lot of enclosed spaces, a lot of walk-in coolers and freezers, you can dedicate a whole zone into that space. Then you would take that sample, so it finds refrigerant, brings it back here, it's analyzed, it's over, it's over 1,000 in this case, it's set that at 1,000, and it's going to go down to your EMS system. That EMS system is going to say, hey, you got a huge leak, set off a horn and strobe, and keep people from going in here, alerting them. And once that door is open, that gas is going to spill out into this area anyway. But you really want to be alerted. But you don't want that horn and strobe going off all the time because you're going to alert shoppers and things, and that's not really necessary. So in this case, what about a low part per million leak? Well, this has 3 levels of alarming. And in this case, you could say, well, I just want small leaks to go out as an email or an SMS to my guys to let them know, But I also want to have an elevated one, let's say more like 10 or 20 parts per million, where maybe it goes to a different set of people that make it happen even faster to get a guy out there to fix the leaks. Okay, well, now let's say I'm a larger store and I have too many of these boxes. I'd be using all my 16 zones in these boxes. Now, you can't split a zone into boxes. You got to keep one dedicated per space in this case. So what do you do there? Well, I would suggest to you that in that case, if you have a few places, use that less expensive leak detector inside the box for safe space, and then dedicate your regular zone somewhere outside the box to cover a large area. So let's say this is a deli cooler or something. Well, if you have this sensor on the outside of the box, this tube here, it's going to find leaks in a range around that, and you could have one in a in a deli case. But anytime someone would open this door up, if there was a leak in there, it's going to pour out into that hit that anyway. So you're going to start seeing it. And I really recommend you look at these videos to see how sensitive these things are. I mean, it's pretty impressive. So anyway, that's what I have for this video, and I appreciate any support you can give our company. We do sell parts and pieces, units we don't install, but we can help you with figuring out what you need to do. We can do that globally. Thank you very much.